We will now see another example of adapter design pattern. I'll create a new project. We'll call this flight simulator. Let's close all the files. And we'll make flight simulator as a starter project. The project that we are creating is a simple flight simulator. The player can fly different kinds of planes. To control the plane, we have mapped the input to some keys on the keyboard. To make the plane go up and down, the input is mapped to up and down arrow key. And for turning the plane in left and right direction, the input is mapped to left and right arrow keys. The player may also want to use a different kind of input device to control the plane. For example, the player may use a game controller. So that's why we would like to design our game in such a way that the player can use any kind of controller to control the plane. Therefore, we don't want to hardcode the game input to a keyboard. We want to have a design where the game can take input from any kind of controller. So let's get started. Let's design the input classes through which the player can give input. First, I will add a class called as input. This will be a base class and it will contain the interface for accepting input from any kind of device. These four methods represent the basic input for controlling the plane. Up and down are used to control the pitch of the plane, that is, whether the plane goes down or up, and left and right are used to control the direction in which the plane will fly. Now, these do not necessarily map to the keys on the keyboard, but these are just abstractions of the different ways a player can give input to the game. Next, we will add a class through which the player can give input through the keyboard. So we will add a class called as keyboard. And we will not actually take input from the keyboard. That will make the code quite complex. So we will return true or false randomly from these functions. I will return the random values of true and false by using the random number generator of C++11. First, we need a random engine. I'm going to use the default random engine. We have to specify a seed value here. Let me give this as the seed value. Ideally, this should be taken from the system clock, but we'll just keep it simple and use a hard-coded value. But this would mean every time it will generate the same true and false values. And that's okay for our example. I'll create an internal function that will use the engine to return random Boolean values. Now we have to use a distribution clause that will internally use the engine to generate random Boolean values. We will use the class Bernoulli distribution. The constructor of this class will accept a float value between 0 and 1. This indicates what is the probability of generating true and false values. 0.5 indicates there is a 50-50 chance of generating true and false values. Then we will invoke the function call operator on the distribution object and we will pass the engine as the argument. And we will invoke simulate input from other functions. We are done with the keyboard class. Now let's simulate that we are using this class in our game. Instead of adding classes to represent the game, I will just add a function called as game, and it will only accept input through the base class. We'll simulate input in a loop and we'll check if input is up. Then we will print a message, pitch up. This means the plane is going up. Otherwise, if the input is down, then we'll print a message pitch down. Otherwise, we will simply print plane is level. And next, we will check for the direction, left or right direction. I would also like to add a delay here. We will decrement count here, and for this literal, I need to open the standard namespace. This is it. And we will create instance of keyboard and call game. So this is the output. You can see the input is being randomly generated. If we run this again, you will see the same kind of input is being generated. This is because we have used the seed as a constant. So these are the input classes in our game. Now, if we want to support more kinds of input devices, we just have to add new classes. Existing code need not be modified.